Hi, my name is Lorraine, and today I want to introduce the red-black tree as my technical presentation. So first, before we start, we want to make sure the goals of this presentation is well clear. First, we need to understand the basics of red-black trees, and second, we need to show the possible implementation of inserting an element to a red-black tree in Java. And to briefly introduce red-black tree is a type of data structure that helps stores information, mostly integers, in a sorted way. Um, and fundamentally, it is a binary search tree that has the ability to self-balance. When a number of children on one side from the root is drastically different from the other, from the other side of the root, it will be very costly to do any operation, including like insert, delete, everything. So in order to avoid such a potentially expensive situation, we make the nodes of a binary search tree to have two different colors, red and black, so that the tree would be constructed in a way that avoids having imbalanced children. So let me go through the rules of implementation for a red-black tree. So first, we need to make sure that the root is always black. And second, every node must be either red or black. And third, there should not be any consecutive red nodes. And fourth, the number of black nodes from the root to a null node must be the same across the tree. So that means that we need to make sure that all of the four rules are implemented so that we will have a valid red-black tree. And now let's take a closer look at one of the operation, which is insert. So before that, let's take a look at an example of a red-black tree. So for example, we will have 10 as the root, and then on the left hand side is his children, black, and then on his right hand side is his other children, 11. And as you can see that from 11 there are like different children from that as well, like 9, 12, 13. It is note that it is still a binary search tree, which means that the left hand side must be smaller than the right hand side. And also, there are no two consecutive red nodes here. We can see that the distance from the root to the null root node is two red nodes. Therefore, no matter how you do it, it is always going to be two black nodes. And let's take a look at insert. So first, we want to insert something to the red-black tree. We will have a general add function, which functions like just a normal insert function in any binary search tree. Basically, it uses recursion. So if the value compared to the root is smaller, then we will recur on the left subtree. And then if it is greater than the root value, then we will recur on the right tree. So this is basically this general function. However, note that we have some helper functions here. For example, like adjust after insert, and also set right, etc. So now let's take a look at the next slide. So first, we want to know that how to rebalance the tree if there are like two consecutive red nodes. For example, now we need to check that of like the root now, the parent of it is red. So basically, we just basically recolor the different nodes that has confliction of two consecutive red nodes, and we move up to see if more work is needed. And then for the next step, we will reconstruct for a parent who is the left child of the grandparent. This will require a single right rotation if n is also a left child, or a left child rotation otherwise. Here we can see that we basically check if the parent of a node is the same of its left of its grandparents. That way we know that there should be a confliction, and if not, then we can like switch it. And similarly, we can do it with the right-hand side as well. So we reconstruct for a parent who is the right child of a grandparent. This will require a single left rotation if n is also a right child, or a right-left rotation otherwise. So this is basically the reverse version of the previous slide. And now if we do that, we have a valid insert function, and we can just like keep using the insert function until we reach certain amounts so that we can have a valid red-black tree. And that's basically it, where we can construct a red-black tree, and that's the introduction for it. And now here's the reference of my presentation. And thank you.